Hello everyone. In today's lecture we are going to see next point from quantum mechanics or the quantum chemistry, and it is a very important point to find out energy. So today's point of discussion is the Schrodinger equation. In a classical mechanics, the observed behavior of macroscopic particles is governed by Newton's laws of motion. So simply classical mechanics is applicable for the larger objects which obeys the Newton's laws of motion, and the behavior of microscopic particles could not be explained on the basis of classical mechanics. As we already know that moving microscopic particles has wave nature, therefore, there must be some wave equation that governs it. And in 1926, Erwin Schrodinger adapted classical wave equation to microscopic systems, that is for smaller objects, by the use of de Broglie hypothesis, and obtained an equation which is the famous Schrodinger equation. And Schrodinger equation is a fundamental equation of quantum mechanics, as Newton's laws are basics of classical mechanics. So simply the Schrodinger equation is useful for microscopic systems or for the smaller objects. So we will see now the formulation of the Schrodinger equation. For that purpose, consider a system such as a string vibrating with frequency nu and the producing a wave traveling in a x direction with a velocity v and amplitude u. So simply consider here frequency is nu and the direction is x. Velocity of the object is small v and amplitude is u. So, according to the classical mechanics, the equation is given here. Del square u divided by del x square is equal to 1 upon v square into del square u divided by del t square. Here t is the time which is necessary for the wave to reach a position x, and this equation can be solved by the method of separation of the variables, and this can be written as the product of function of x and a harmonic function of time t. So simply in the classical mechanics the equation is given del square u divided by del x square. Here u is the amplitude, x is the distance, is equal to 1 upon v square. Here v is the velocity and into del square u divided by del t square. Here t is the time which is necessary for the wave to reach the position x. So this is the equation which is taken from the classical mechanics. This is our equation number 1. And the amplitude u xt is equal to psi of x into cos 2 pi mu t. Here this is equation number 2 and here new terms are included now. See, here psi is the wave function and remaining part is given here cos 2 pi mu t. Here nu is the frequency, t is the time and pi is the constant term. So simply amplitude in direction x and in time t is equal to the wave function into cos 2 pi nu t. This is our equation 2 for the amplitude. Now psi of x is a special factor of the amplitude u xt of the wave, and nu, this nu is the frequency. Now we are going to differentiate equation number 2 with respect to x. So this is our equation number 2 and we are going to differentiate this equation 2 with respect to the x, that is change in position. So simply equation will be written as du divided by del x is equal to d psi divided by dx, and remaining terms will be as it is. So equation can be written as del u divided by del x is equal to del psi divided by del x, and remaining part is as it is into cos 2 pi nu t. This is our equation number 3. Now again take a derivative of equation number 3, that will be the double derivative of equation number 2. It can be written as del square u divided by del x square is equal to del square psi divided by del x square, and remaining part as it is cos 2 pi nu t. So this is our equation number 4. So this is the first derivative, this will be the second derivative. Now differentiating equation 2 with respect to time t. Now this is our equation number 2. U x t is equal to psi of x into cos 2 pi nu t. So write the equation in terms of the change in temperature, change in time, sorry. So equation can be written as du divided by del t is equal to psi of minus 2 pi nu into sine 2 pi nu t. So simply by taking differentiation of the equation number 2 with respect to time t, the equation will become as like this. Del u divided by del t is equal to psi, the work function, into minus 2 pi nu into sine of 2 pi nu t. So this cos will become sine. So sine 2 pi nu t. Now this is our equation number 5. Here differentiation of equation number 5. After that we will get a equation. So just take differentiation again of this equation number 5. So it will come del square u divided by del t square. This will be the second derivative simply. Psi as it is minus 4 pi nu, it will become into 2 pi nu. So simply equation will be minus 4 pi square nu square into this sine will again get converted into cos. So cos 2 pi nu t. Here nu is there, it's remaining here. So simply equation is del square u divided by del square del t square is equal to psi and minus 2 pi nu into plus 2 pi nu, it will become minus 4 pi square nu square, and sine will convert it into cos. So cos 2 pi nu t is here, and this is our equation number 6. Now substitute this equation number 4 and equation number 6 in our equation 1, this equation. So d square u divided by dx square, this is the equation left part. So simply just put equation number 4 and equation number 6 in equation number 1. So equation will be written as del square psi divided by del x square into cos 2 pi nu t. So this is equation number 4. Del square psi divided by del x square into cos 2 pi nu t. This will be the left side is equal to 1 upon v square in bracket minus 4 pi square nu square into cos 2 pi nu t into psi. This is written here. So here from equation 4 we can get value of this d square u divided by del x square, and from equation 6 we will get value of this d square u divided by del t square. So just put equation 4 here and equation 6 here and write the equation as equation number 7. So this is the equation. Del square psi divided by del x square into cos 2 pi nu t is equal to 1 upon v square. Here v is the velocity and nu is the frequency. These two terms are different. That's why I have highlighted v here. 1 upon v square in bracket minus 4 pi square nu square into cos 2 pi nu t psi. This psi as it is here. This is the work function. So this is our new equation. By combining equation number 4 and equation number 6, when these two equations kept in equation 1, we will get equation number 7. Now just cancel the similar part. At the left side cos 2 pi nu t is there. Obviously at the right side this term is there, cos 2 pi nu t. So these two terms will get cancelled. So remaining equation is d square psi divided by del x square is equal to minus 4 pi square nu square divided by v square into psi as it is. So just transfer this negative part to the left side and it will become positive. Del square psi divided by del x square plus 4 pi square nu square divided by v square into psi is equal to 0. Here v is the velocity and here it is a nu. This is a frequency. Now by using relationship between the frequency and the wavelength, so nu lambda is equal to v. So v is the velocity which is equal to frequency into wavelength. So simply we can write nu is equal to v upon lambda. So we want v square value, nu square value or the frequency square value. So it will be v square divided by lambda square. And in this equation we can put the value of nu square, which is equal to v square upon lambda square. So just v square get cancelled and remaining equation is only nu square is equal to 1 upon lambda square. So our equation 7 can be written as del square psi divided by del x square plus 4 pi square divided by lambda square and psi as it is equal to 0. So this is our equation number 8. Now equation of energy, as we know the total energy is the sum of kinetic energy plus potential energy. So this is equation number 9 and kinetic energy is equal to how much? Half mv square. M is the mass and v is the velocity. So simply this is the equation number 10. Multiply and divide this equation number 10 by m. So kinetic energy is equal to mv bracket square divided by twice m. So just multiply this by m and divide the equation 10 by m. So equation can be written as in bracket mv bracket square divided by twice m. And we know the definition of the angular momentum P, which is equal to mv. So just kinetic energy is equal to p square divided by 2m and potential energy can be written as v of x, or the potential is given by v simply. So kinetic energy equation p square divided by 2m, this is our equation number 11. Now from equation number 9, total energy is equal to kinetic energy plus potential energy. Now we have both kinetic energy and the potential energy. Just put values in the equation number 9 and we will get equation this. E is equal to p square divided by 2m plus v of x. Here p square by 2m is the kinetic energy and v of x is the potential energy simply, and this is equal to E. Here we want value of the p. So just rearrange the equation. E minus v of x bracket complete into 2m is equal to p square. Just take square root and find out the value of p. So p is equal to square root of 2m in bracket E minus v of x. This is our equation number 12 and we know the de Broglie relation to find out wavelength. Lambda is equal to h upon p. So simply put value of p here. h by square root of 2m in bracket e minus v of x. So this is our equation number 13. Now just put equation number 13 in equation number 8 in this equation. So equation number 13 is of lambda, and here in equation 8 we have the lambda square. So by just putting value of lambda in equation number 8, we will get the final equation d square psi divided by del x square plus 8 pi square m divided by h square in bracket e minus v of x bracket complete into psi. Psi is the work function and whole terms is equal to 0. This is the equation number 14, and this equation is called as a Schrodinger equation, and this equation is a time independent Schrodinger equation because in this equation does not contain small t, and it is a differential equation whose solution psi of x describes a particle of mass m moving in a potential field which is described by v of x.